Have you ever wondered why the sea is blue? It's a question that has puzzled many, from curious children to seasoned scientists. It's a simple question, but the answer is a fascinating journey into the world of science. The blue color of the sea is not just a trick of the eye, it's a complex interaction of light and water. When you look at a glass of water, it's clear. This clarity makes it hard to believe that the vast ocean, made up of the same water, can appear so vividly blue. So why does the ocean, filled with trillions of gallons of water, look blue? The answer lies in the way light interacts with water molecules. The answer lies in the way light interacts with water. When sunlight, which is made up of all the colors of the rainbow, hits the ocean, the water absorbs colors at the red end of the spectrum and reflects colors at the blue end. Get ready, junior scientists, because we're about to dive deep into the science of light and color. We'll explore how the depth of the water, the angle of the sun, and even the particles in the water contribute to the ocean's mesmerizing blue hue. So grab your goggles and your curiosity, and let's embark on this scientific adventure together. Water in its purest form is transparent. Think about it, you can see right through it. Whether it's a small puddle or a bathtub full of water, the water itself doesn't have any color. But something incredible happens when we look at massive amounts of water, like the ocean. The water's interaction with light changes, and that's where the blue color comes from. Light might seem simple, but it's actually made up of all the colors of the rainbow combined. This phenomenon is something we encounter every day, yet it holds a world of wonder within it. When we look at a beam of light, we are actually seeing a combination of many different colors, all blended together to create what we perceive as white light. We can see these colors when light is split through a prism. The prism acts like a magical tool, separating the light into its constituent colors, revealing the hidden spectrum. This process is called dispersion, and it allows us to see the vibrant array of colors that make up white light. Each color of light travels in a wave, and each color has a different wavelength. These wavelengths determine the color we see. For instance, the waves of red light are longer, while those of violet light are much shorter. This difference in wavelength is what gives each color its unique place in the spectrum. Red light has the longest wavelength, while violet light has the shortest. This is why red light appears at one end of the spectrum and violet at the other. The varying wavelengths of light interact with the environment in different ways, creating the beautiful colors we see in nature. When all these colors are combined, we see white light. This combination is what makes sunlight appear white to our eyes. It's a perfect blend of all the colors, working together to create a harmonious whole. But when light hits water, something fascinating happens. The water acts like a natural prism, bending and splitting the light into its component colors. This is why we often see rainbows after a rainstorm, as the water droplets in the air disperse the sunlight, creating a beautiful spectrum of colors in the sky. Section 4. The Great Color Absorption. Water is great at absorbing light, but it doesn't absorb all colors equally. It prefers to absorb the warmer colors first, like reds, oranges, and yellows. As light travels deeper into the water, these colors are absorbed quickly. The cooler colors, like blues and greens, are absorbed much more slowly. This means they can travel further through the water before disappearing. Section 5. Blue skies and blue seas scattering light. So, why do we see blue? It's a question that has fascinated scientists and curious minds alike for centuries. It's all thanks to scattering. When sunlight enters the Earth's atmosphere, it is made up of different colors, each with its own wavelength. As light hits the water molecules, the blue light is scattered in all directions. This phenomenon is known as Rayleigh scattering, named after the British scientist Lord Rayleigh who first described it. This makes the water look blue to our eyes, especially in the open ocean where the water is very deep. The deeper the water, the more pronounced the blue color becomes because the red, orange, and yellow wavelengths are absorbed more quickly than the blue. Sometimes the sea can appear green or even brown. This variation in color is due to the presence of different substances in the water. This is because of things like algae in the water. Algae contain chlorophyll, which absorbs red and blue light, reflecting green light, giving the water a greenish hue. Or sediment being stirred up from the bottom, which can make the water appear brown or murky. Sediments can include sand, silt, and organic matter, all of which affect the way light is absorbed and scattered, which can change the way light is absorbed and scattered. The presence of these particles can significantly alter the color of the water, making it appear less blue and more green or brown. But in most cases, the vast expanse of the ocean appears blue because of the way water interacts with light. The interplay of light and water creates a mesmerizing blue that has inspired countless artists, poets, and dreamers throughout history. So next time you gaze out at the ocean, remember the fascinating science behind its beautiful blue color.